Friends, welcome to Code Sutra. In this video, we will be solving LeetCode problem number 109, converting a sorted list to binary search tree. For example, in this problem, we are given the head of a linked list and this has to be converted to a binary search tree. For example, this particular linked list will be converted into this binary search tree. So, what is a binary search tree actually? In a binary search tree, the left nodes or all the left elements will be lesser than the root node. For example, is -3 lesser than 0? Yes, right? All these values are lesser than 0 and all the values on the right are greater than the root element, that is 0. This is true for any node. Let's take a random node, this, right? 5. Is 3 lesser than 5? Yes. And is 9 greater than 5? Yes. So that is the property of a binary search tree. And the second thing is, it is given, it has to be balanced. What do you mean by balanced? Balanced means the left tree and the right tree should have almost equal elements, or in other words, the height difference should never be greater than or equal to 1. For example, what is the height of the left and the right subtree? It is 2 and 2. So they are balanced. So that is the idea. The key word that is given here is the linked list is sorted. That is the main idea, right? So if it is sorted, and if we just find the middle element here, all the right nodes will be greater than this. So this will be our root node and all this can just be our right child, right? Because why? They are greater than that. Similarly, all that are on the left can be our left subtree. It is very easy, right? So let's go on how we can form with this given linked list. The first thing that we will be doing is we will find the middle element, that is 0, and we will say this will be our middle element. The right side will be our right side and the left will be our left side. So this will be our root node. What do we do next? So we ask the same function to form a tree and make this the left child. For example, this function we'll call again. So we'll find the middle element again. -3 will be our middle element. -10 will be our left tree. -1 will be our right tree. So since they are just one node, can we directly form it? Yes, right. So -3 will be on the left side like this, and -10 will be on the left of -3 and -1. Similarly, on the right side also, we are again calling the same function. What it will do? It will find the middle and the left and the right, and it will say form me a binary tree and give. So if you look here, we are calling the same function recursively. What we are doing is we are finding the middle element, making it the root. Then whatever is on the left, we are again calling the same function. So we can use recursion for this particular problem. So let me dive into the code. So before that, how do you find the middle element in the fastest possible way? So how do you find the middle element in the fastest possible way? We will have two pointers, that is the fast pointer and the slow pointer. The key idea here is one will move 2 times the speed of the other. For example, if it moves 2 steps, the slow pointer will move 1 step. Why are we even doing this, right? Say for example, take a circle. One is moving at twice the speed and the other one is moving at half the speed. So when this fast person completes the circle, where will be the first person? He will be exactly at the middle, right? Or say take a 100-meter race. One is running at 2 speed and the other one is running at 1 speed. Once he completes, where will this guy be? He will be exactly at the middle, right? That is at 50. So that is the key idea. What we will do, we will initiate both of them to the head pointer. The slow pointer will move 1 at a time. The fast pointer will move 2 steps. The slow will come here. The fast will move 2 steps at a time. Again, slow will move 1 step. The fast has arrived at the end. If you look here, this is exactly at the center or the middle. So we find this middle and we recursively call the left and the right subtree to form their own subtree. So let's dive into the code. Before diving into the code, if you are one among them, please do consider subscribing to the channel. So without further ado, let's dive into the code. What are we doing in this? We are finding the middle element and we are initiating the root element. We are creating a new root element, that is with the middle dot value. We are finding the middle element. For example, in this example, we are finding the middle element and creating a whole new node out of it. And the right tree and the left tree, we are forming it again. We are forming the right tree is equal to middle dot next. And remember this, middle dot next, we have to set it to null. Why do we have to set it to null? Because the left tree should not contain all the elements, right? So we are setting it to null, and again we are forming the left subtree. First we are forming the right subtree and then we are forming the left subtree. Why? Because just because we want to set all the elements after the middle to null, so we are forming the right tree first and then the left tree. Finally we will return the root at every step. So, and this is the code to get the middle element of the linked list. Thank you for watching the video. Please do like, share and subscribe.